Hey guys, welcome to my channel, Learn with a Froz. I'm a Froz, the knowledge man, and we as students, we often get very surprised when new topics come upon us. Sometimes we feel the new topic is from a whole different world, and of course, so we have hard times dealing with them. Of course, there are many great teachers doing very great stuff teaching children, but still, a fair amount of children have difficulties in learning. I will be dealing with topics in math and sciences, and I will elaborate them in such a way that they're directly related to our lives. In my videos, you will see that these studies we do are actually related to real life, and they're connected to us. I know that it's a whole different ballgame when we're connected to our studies and we can understand them better. And of course, when we can connect them and understand them better, our interest in studying increases and of course, our grades go up. In math, topic introductions will be extremely important because I'll explain the theory and background of the topics, and I'll build up your confidence in such a way that the exercises will be easy peasy. Today's topic is the intro to quadratic equations, and today we will try to understand what quadratic equations are. So let's go.
Let's review equations. So what's an equation? An equation is a relationship between two or more quantities. So it can be like F is equal to W, force is equal to weight, or it can be like W is equal to mg, weight is equal to mass, the product of mass and gravitational acceleration. Or it can even go up to F is equal to G m1 m2 divided by d squared, where this is force, F is force, G is gravitational, gravitational force, gravity, force of gravity. M1 is and M2 are the masses of the objects, and d squared is the square of the distance between them. And in algebra, we use variables. So instead of these type, we're learning algebra today. So instead of equations which have these quantities, F, G, M1, M2, instead of these quantities, we use numbers and variables. Like an equation in algebra could be 2 plus 7 is equal to 9. And then using a variable, we could make it x plus 7 is equal to 9. And then we could turn this into x is equal to 9 minus 7, and then x is equal to 2. So finding the value for x, which we just did, we found the value for x, which is x is equal to 2. When we find the value for x, we call it solving for x. So we solved this equation, x plus 7, to get x. Now, here we can see that x plus 7 is equal to 9, or if we have something like x minus 8 is equal to 3, or x plus 10 is equal to 0. Something like this. This one, and this one, all three of these are linear equations. So linear equations only have one solution, meaning one value of x, and they are linear equations because the max value or power, or the value of the exponent of the variable, which is here x, is 1. Exponent, power, value of the power, whatever you like to call it. It's 1 here, and 1 here. This power, it all depends on this. If we have something like x squared plus 5x minus 9, plus 9 actually, let's try it, is equal to 0, or, sorry, not x cubed, x squared minus 9x plus 3 is equal to 0. If we have something like this, then these are all quadratic equations. Quadratic equations. And if we have some, let's write the examples under the type. So here are linear equations. So in algebra, we learn different ways to solve different types of equations. And examples are, of course, these linear equations, quadratic equations. There are also cubic equations and quadratic equations. So let's see some examples of linear equations. There can be x minus 2 is equal to 0, x plus 2 is equal to 9, or x minus 9 is equal to 20, even something like that. And quadratic equations can be like x squared minus 9x is equal to 0, x squared plus 5x minus 3 is equal to 0, or x squared minus 3, sorry, not x3 is equal to 0. These are all quadratic equations, and this is because of the value of the exponent of the variable, the max value. That's 2. So they're quadratic equations. And then in cubic equations, we have something like x cubed plus 1 is equal to 0, or x cubed minus x squared plus x minus 90 is equal to 0. You know, something random. I'm just making these up, so. But they're still cubic equations. All that we need to do to have a cubic equation is that this value of the exponent, or the exponent, it must be max 3. There can't be one higher than that. Or there can be x cubed minus 5x is equal to 0. Stuff like that. And then there are quadratic equations, which are x raised to the power 4 plus 29 minus 8x plus 2x squared is equal to 0, or x raised to 4 plus 3 minus x is equal to 19x squared plus 3x cubed. Something like that. It doesn't matter if you have a variable in this equation which has a cube. That doesn't matter. Sorry, I said variable. I think I meant variable. Or if there's an x squared here, that doesn't really matter. It all just matters that the max power is 4. It doesn't go above that. If this was, say, not here, if this wasn't here, then this would be a cubic equation just because the max power is 3. But of course, we're trying to give examples for quadratic equations, so we do have x raised power to the 4th. Anyway, let's get back to our topic, quadratic equations. Okay, so it makes a bit sense, I think, that cubic equations are called that way because cube and linear also makes sense, so does quadratic because quad. But why are these called quadratic? Why not squared or something like that? This is because quad means, the word quad means squared. And the square of what, you might be thinking? The square of the variable. So in quadratic equations, we mean x squared. Or it can even be y squared. There's no going against that. I just wrote x as the variable for all of these, but it's actually supposed to, I mean, not supposed to be, but it can be any other letter as the variable. But in algebra, we usually use x, y, and z. Usually, we can use a, b, c. We also see that very much. But anyway, if we see an equation in the form ax squared plus bx plus c is equal to 0. And by the way, the amount of values of x, all of them, they depend on the type of equation. For example, linear equations, they only have one solution because the exponent, actually, yeah, we should say exponent. It depends on the exponent of x. That's 1. Quadratic equations, x has 2 values, 2. In cubic equations, we see that the max power is 3. No more than that, no less than that. So x has 3 values. And of course, same goes for quadratic equations. Since there's a 4 here, they're going to have 4 values for x. Anyway, back to here. ax squared plus bx plus c is equal to 0. If we see an equation in this form, provided a is not equal to 0, this is a quadratic equation written in standard form. Written in standard form. So this is written in standard form. And the part where we say that a is not equal to 0, this doesn't only apply for if it's in standard form. It applies for any form. If it's in the form written as ax squared minus c is equal, plus, actually that doesn't matter. Minus c is equal to bx. Doesn't matter, it's still a can't be equal to 0 because if a is 0, then it's going to be 0x squared. And that way, there is no x squared. And when there's no x squared, it's going to be a linear equation then. Because there won't be any max power with 2. The max power can possibly just be x raised power to 1. Right? So that's why it's going to be a linear equation then. So you can't write 0x squared plus 5x minus 9 is equal to 0. This isn't a quadratic equation. It's just going to turn into 5x minus 9 is equal to 0. That's it. Which is a linear equation. Linear. Then there are pure quadratic equations. Pure quadratic equations. So what's a pure quadratic equation? So we know that the standard form is ax squared plus bx plus c is equal to 0. Now, all we need to do, we don't need to do anything actually. Now in this equation, all we said is that a is provided that it can be equal to 0, and we know that it can never equal 0. You can't have a pseudo like this one. You're going to end up with a linear equation like this one. So, we only said a can't equal 0. There's no going against b or c being equal to 0. This is totally fine. Correct. So, interestingly enough, when the coefficient of x, x, which is b, is equal to 0. So it's going to be written in the form ax squared plus c is equal to 0, because ax squared plus 0x plus c is equal to 0. You're obviously just not going to have to write this because it's just not needed. It's literally 0, and 0 doesn't make a difference unless you're multiplying or dividing, which we're not doing. We're just adding. So when we see that an equation is written in this form, we instantly know that this is a pure quadratic equation. Pure quadratic equation. Next we have on the list are hidden quadratic equations. Hidden quadratic equations. So what are hidden quadratic equations? Hidden quadratic equations are the quadratic equations which don't really look like they're quadratic or actually equations at all. They look like simple expressions such as x plus 1 over x plus x over x plus 1 is equal to 1. Something like this. It doesn't look quadratic at all, does it? It may be a linear, it may be, cubic. We can't tell. So, all we have to do here is simplify it a bit, and we'll see how it's quadratic, or cubic, or quadric. We'll see that. So, let's see. What do we need to do? We can see that here their denominators, fractions, so of course they have denominators. So it's simple. Multiply all these terms by this product of their denominators, which is x into x plus 1 into this x plus 1 divided by x. So these two cut out, plus x into x plus 1 divided by x plus 1. These two cut out, and we get is equal to 1 into x plus 1. Here we get x plus 1 whole squared, x plus 1 whole squared, plus x into x is x squared, is equal to, here, x into x is x squared, and x plus 1 is x. So we get x squared plus x. Opening this formula up, we're going to get x squared plus 2x plus 1 plus x squared is equal to x squared plus x. Now let's send this x squared to the left-hand side. Or actually, sorry, this whole term to the left-hand side. We're going to get x squared plus x squared plus 2x plus 1. These two are going to turn negative, so minus x squared minus x is equal to 0. These two cut out. We get x squared plus 2x minus x. 2x minus x is going to give us x. And then we have a plus 1, so plus 1 is equal to 0. We can see here that this is a quadratic equation, and on top of that, it's a quadratic equation written in standard form, in the form ax squared plus bx plus c is equal to 0. It's written in this form, isn't it? And a is equal to 1, so a is not equal to 0. that's it for today's video, guys. Hopefully you got everything there is. If you have any confusions, please leave your comments in the comment section. I'm going to read and reply to all of your comments. Peace is what I think they call it.